Here's CPM Precalculus, Chapter 1, Number 30. So solve for x in each triangle below. Well, if we look at all these triangles, we can see one thing that is in common in all of them is that they are right triangles. So this helps us, allows us to do two things. What do we know about right triangles? We know the Pythagorean theorem. Pythagorean theorem. And that's basically saying c squared equals a squared plus b squared, where c is the hypotenuse. We also know SOHCAHTOA, right, where sine of an angle is the opposite over hypotenuse. Cosine of an angle is equal to the ratio of the adjacent side divided by the hypotenuse. Tangent of an angle is equal to the ratio, so it's opposite divided by adjacent. So let's look at A first. Part A, we have a right triangle and we have an angle here of 26 degrees. So we want to solve for x. So if we can look at all three. So since we have an angle, the Pythagorean theorem doesn't really help. So we want to look over here at SOHCAHTOA. We have an angle, we want to try sine. What is sine of 26 degrees? Well, we know sine is going to be the opposite side. We don't know what this opposite side is, so it's question mark divided by hypotenuse. That's the O. So in SOHCAHTOA, so divided by 18. Cosine of 26 degrees is equal to adjacent x divided by our hypotenuse, which is 18. Tangent now is going to be SOHCAHTOA. Opposite is our question mark again, and adjacent is x. So if we're trying to solve for x, we need to look at which one we should use. Should we use sine, cosine, or tangent? And I'm going to say right now that it's kind of obvious that we should use cosine because sine and tangent both have these question marks. And those question marks mean that we need more information. So we are left with cosine of 26 degrees is equal to x over 18. Now how do we solve for x? Well, what you can see is if we multiply both sides by 18, 18 cancels out here. So we're left with 18 times cosine of 26 degrees is equal to x. And now what we can do now is simply plug this in our calculator. And I'm going to do it right now. And 18 times cosine of 26 degrees is equal to 16.17829,283. So we can say x is approximately 16.18. And when I say approximately, I should use those squiggly lines like that. So that's in part A. Part B. Okay, so let me do part B. Add a new layer. So B. So we know we found A. So B, we're looking at B. Again, we have our right triangle and we have a 70-degree angle. So when we have the angles again, we want to use SOHCAHTOA. And one way you could look at it is without writing them all down. You know, sine is opposite, which is our question mark, over hypotenuse, which is x. So we don't want to use that one because it has the question mark again. Cosine is adjacent over hypotenuse. So that one looks like the one we want to use because we know the adjacent is 8 and x is the variable we're looking for. So cosine of 70 degrees is equal to 8 divided by x. So now that we have this formula, we have to get x right here, this x, on its own. And we want to isolate it, and our answer is going to be basically x equals something. So to do that, we need to get it out of the denominator. So first, we multiply both sides by x. So that gets it out of the denominator, cancels it out on the right side. And we have x cosine 70 degrees is equal to 8. Then we just divide both sides by cosine 70 degrees. cosine 70 degrees, and we're left with x is equal to 8 over cosine 70 degrees. We plug this in our calculator, 8 divided by cosine 70 degrees, and we get x is approximately 23.3904352. So we can say x is approximately, so we're saying approximately, we use squiggly equals is 23.39. And that's part B. So let's move on to part C. Okay, C, if you look at this right triangle and C, we are given just the sides. We don't know anything about the angles. So that's where we want to use the Pythagorean theorem. THM is short for theorem. So C squared is equal to A squared plus B squared. C, of course, is the hypotenuse. Hypotenuse, again, is always across from the right angle. No matter what triangle, it has to be a right triangle for this to be true. So we could always look at the right angle and look across. That's our hypotenuse. So 22 squared equals A squared plus B squared. A and B, it doesn't matter which of the legs of the right triangle we use. So I could just say A is X and B is 10. So then I want to say X squared plus 10 squared. And the rest of this problem is just solving for X. So 22 squared, I'm plugging my calculator, is 484. That's equal to X squared plus 10 squared is 100. Subtract 100. Hello, Brenda. Is equal to 384.
Oh, Lara says she wants to pass to like know that we're here.
Okay, 1 minute. I'm making a video. No.
Oh, your YouTube video?
Yes. So say hello.
Hello. Hello. Hi. Who's this for?
Oh, man. Okay, so we're getting interrupted. 384 is equal to X squared. So we square root both sides. To get X alone, we get
Why are we here?
19.5959 is equal to X. And because we square rooted, we have to do plus or minus. But because we're looking at lengths of a triangle, we only look at positive. So part C is X is 19.596 approximately. Okay, and because people are here, I'm going to stop this problem. You could do D on your own. D looks more like A and B.
What are you talking about?